minutes for people to come in. Okay, I see participants are coming in little by little, so welcome. For those of us that are joining just now, please do let us know where you're connecting from. So feel free to use the chat just to say hi. It's always nice to see where people are coming from. Good morning to you, Alexander. Yes, welcome. Okay, well, I suppose I'll start little by little in introducing the webinar, just to allow more people to come in. So today we're having this webinar, which is how DestinE can empower sustainable cities. And we are showcasing in particular a use case for the DestinE platform named CITYNEXUS. So overall, we know that traffic congestions, poor air quality, these are some of the common challenges for numerous urban areas, and innovative tools that empower the decision makers in the field of urban planning can ease these detrimental consequences and improve citizens' lives. So in this webinar, and thank you for joining us, we delve in particular to the CITYNEXUS application. It's a novel urban tool designed to tackle the challenges of urban development decisively. So in this innovative solution, this is powered by the DestinE platform. It leverages advanced data integration and AI to provide policymakers and urban planners in Copenhagen with specific what-if simulations. So we will explore the significant impacts of urban planning, environmental sustainability, and public health. And in this webinar, we'll learn how CITYNEXUS fosters informed, community-driven decisions towards achieving a sustainable, smart urban future. Today, we will hear specifically from Simone Frattini, who joins us from Solenex. He's a principal research engineer. And we also have Alessandra Feliciotti, who is the operations manager of MindEarth. So with this, I'll pass the floor to Simone, who will provide a quick introduction, and then on to Alessandra after. So Simone.
Thanks, Rob. Good morning, everybody. I am sharing the slides. Hope you can see them.
Yes.
Thanks, Rob. So good morning, everybody. I mean, this CITYNEXUS, it's a partnership collaboration between Solenex and MindEarth. Solenex is a German company, which is a branch of a Swiss company that have been working for the last 20 years in the intersection between service or space operations, software products, software engineering. We have been collaborating with ESOC in operations, in supporting operations, and in deploying advanced tools for ground segment engineering, spacecraft operations, data processing, and Earth observation applications. One of the core focus of the company is in injecting innovation in space using artificial intelligence. We have been proposing artificial intelligence for spacecraft operations, for Earth observation applications, and trying to spread the concept all around the space segment. I will leave then the floor to Alessandra to present MindEarth.
Yes, hello, thank you. My name is Alessandra. I work at MindEarth. MindEarth is a Swiss-Italian company that was founded first in Switzerland in 2018 and later a branch in Italy in 2023. And we are a consultancy and applied research firm that specializes in spatial data science and analytics. MindEarth's mission is to drive innovation in the geospatial sector for both social and business impact. We have worked with a wide range of international organizations and governments, and then we also are increasingly working with private sector businesses to tackle different challenges related to data-driven decision-making. Our specialty is to work with three primary types of data, which we either collect or process We are specialized in the use of Earth observation data to create accurate maps of socioeconomic and environmental variables across the world. We process large records of location-based mobility data, which is one of the key applications we are also developing as part of CITYNEXUS. And this is to understand commuting habits and mobility habits of populations. And we have our own technology to collect and analyze street-level imagery and data to create accurate and up-to-date maps of cities and urban areas. With Solenix, we are developing this solution, the CITYNEXUS tool, as part of the DestinE. And yeah, I will go just a bit in detail now to explain a little bit the motivation behind this activity, and also to provide a little bit more insight on what are the, let's say, challenges and how we want to address them. So the CITYNEXUS is an urban digital twin application that targets sustainable urban intervention. It's currently in the advanced state of development, and the idea is to help policymakers to essentially rely on a collaborative platform to experiment in a safe and risk-free environment different types of urban transformation and understand their potential impact on different variables. The idea is not only that this tool will be able to support policymakers to really understand the impact in the specific case of mobility on the livability and air quality of urban areas, but also to test different what-if scenarios where they can play with the road infrastructure, they can play with different types of traffic regulation and understand the impact not only on mobility, but also on air quality and by extension on health. If you can go to the next slide, Simone. So this idea really came together with the local council of Amager West, one of the municipalities of the city of Copenhagen, and the motivations were really quite broad. There are growing concerns in the city of Copenhagen, as in many other European cities and cities worldwide, on the need to really address traffic congestion to support the more sustainable urban lifestyles and more locally based lives for citizens and city users. So to this purpose, the city of Copenhagen is currently considering different potential possibilities to really transform their road infrastructure, especially the high-speed segment, which has some key important negative effects on the livability of public spaces in urban areas in the city of Copenhagen, and is considering transforming this infrastructure through very large initiatives. Some of these involve really acting on the presence of this high-speed road that cut through neighborhoods by, for example, tunneling them. But these are very large and important projects which have impacts that are very difficult to understand and to really account for. So together with the local council of Amager West, that basically contains one of the neighborhood of Orestad, that is crossed by one of these motorways, the Orensud motorway. The idea is to understand what if we decide to really tunnel a section of the motorway, and we not only understand the impact in terms of economic cost of this activity, but also we try and understand something different. For example, how does the mobility of the area respond? How does the air quality of this area change? So this was really the key starting motivation that drove the entire project. And since we were there, we really tried to think, how can we bring this idea one step further? So if you can go to the next slide. So the idea was to create a tool that was able not only to allow the city to understand the relationship between mobility and air quality, but also that would allow them to play with different types of transformation scenarios, to understand how population is distributed during the day in terms of mobility, to understand the impact of having more or less services accessible, on how the current situation in terms of mobility impacts air quality, and also to be able to play with each of these parameters and see what happens if we change each and every one of them. So if we go to the next slide, the first very starting point was the data that we wanted to use to make this possible. We relied on what is known as high-frequency location-based data. That is data that comes from GPS-enabled logging devices used by hundreds and thousands of users. And these are used to basically anonymously understand microscopic patterns of population mobility at very, very fine spatial and temporal scales. So this is a type of data that is typically used to understand traffic flows or commuting behavior, to understand when we have peaks of traffic, what places are more used than others. So this was the baseline data that we used for the city of Copenhagen. And this is the area that is currently the focus of this first application. So the wider Copenhagen area. Next. So in this tool, users are given the possibility to play with all these different types of parameters. So they can not only decide to redesign high-speed roads by putting them above ground or underground in a tunnel, as was one of the original plans of the city of Copenhagen, but also they can play with rules that are acceptable on this road. So they can adjust road speed, they can close the road to, for example, motorized vehicles. They can change the proportion of vehicle types. For example, they can increase the amount of electric vehicles versus and reduce the amount of fuel, let's say, of different types of fuels. They can also understand how to change the actual demand of mobility by changing point of interest and, for example, adding new restaurants or new stores in different parts of the city to understand how the mobility demand changes and increase the number of people that live there. And a result of all these input changes that the user can introduce, the model is able to provide an estimate of the impact on traffic congestion dynamically through the course of a typical day, and the impact in terms of air quality. How does the air quality change as a result of these transformations that were introduced? Next. So here we can see a first visualization of the mobility over a typical single day, a working day in Copenhagen. We can see the big roads, the motorways that are particularly congested, and the user, after processing all the simulation scenarios, can have a response in terms of these different types of parameters. So they can understand different types of pollutants, the one that you can see listed here, so CO2, CO, HC, NOx, and different types of PMs. They can have statistics for, let's say, different types of road segment. For example, what's the average speed on those segments, and so forth. They can understand results for different time slots during the day. For example, in this case, we have imagined 8 different time slots, each representing 3 hours of a typical day, either the weekend or the weekday, because we know mobility is very different when people go to work and when they don't. Next. Yes. So I will now leave the word to Simone for the next part of this presentation.
Thanks a lot, Alessandra. So now I'm going to talk about how did we render these needs that we got from our stakeholders into an application and a service for the DestinE. I'm going to talk about what we provide to the DestinE and what the DestinE provides to the application. The CITYNEXUS application implements a classical loop of scenario definition, simulation, and evaluation of the results. It's being provided with a graphical user interface on an interactive web-based visualization, which is based on KVGL. a very known and widely used GIS system. Because of the feature that the system provides for us, but also because being a kind of standard and well known by user of this type of application, it reduces significantly the training time, let's say, because it's more intuitive. But it's also provided as an open API that can be used by automated or by software systems for generating data out of this simulator. How this loop is implemented. As Alessandra has explained, the user can take some decisions. They have a baseline. The baseline describes at the moment the city of Copenhagen. So you have data about all the streets, you have data about all the features, the default features, how they are today at this moment in Copenhagen. Then you can create a scenario out of this by taking some decisions. You have decision points that you can change things on the roads, in the areas. And then you run a simulation. You get your results that Alessandra has described, what kind of output that you can get from the simulation. And then you can implement a what-if analysis on the basis of this, the output of this tool, either based on the rough data that you get out of the tool, implementing data analytics services, or for visual inspection with the graphical user interface. The what-if analysis is supposed to provide actionable input for the user to define new scenarios. So in this sense, this is a loop. On the basis of this, you can generate new scenario, either defining them through the user interface, or automatically generating new inputs directly for the simulator and provide this to the system through the API. What you can do with the graphical user interface? You can work on three sets of parameters: road segment properties, map zone properties, and simulation parameters. These are the mapping of these high-level criteria that Alessandra has defined earlier. In terms of road segment, you can select single street segment on the map, and you can modify parameters like tunneling the road segment, adjusting the speed that is allowed on the street, closing the street to some types of traffic, allowing, for instance, only bicycles. So you define this type of properties on the single streets. The system records what you are doing. Then, at the same time, you have these hexagons on the map, over which you can specify zone parameters. The zone parameters are basically allows you to specify what kind of land use you foresee for this area. Once again, this is you get the baseline, like how's the city now, and then you can define scenario for simulating for the future to check what would happen if your city would be, or your land use, for instance, would be changed in this direction, and you can choose a percentage of residential, commercial, agricultural, and industrial establishment in this area. You can work on the point of interest. As Alessandra said, you can basically work changing the request of accessibility of this area, changing the number of school, for instance, or markets, or different types of point of interest, and you can simulate and change some population dynamics, changing, for instance, to adjusting the population levels in this area. The third group of parameters that you can work with, these are not related to the map, but are related to the simulation itself. So you can define a simulation for different time windows, because of course the results midnight, the simulation might be different, or they are for sure different than 8 AM on the morning. You can choose whether you want to simulate a scenario on a weekday or on a weekend, and you can adjust the traffic composition, choosing percentage of electric vehicles, for instance, that you want to achieve or you foresee in your simulation. All of this is compiled into an input for the simulation. And out of the simulation, you can use the same visualization tool, KevlarGL, for visualizing your results in terms of pollutants, statistics for each vehicle, the parameters that Alessandra defined before. It's important to point out that from the application point of view, this is what we are currently working at this moment. As we said, the service is still being deployed. We still have some months. Now we are working on various directions. So it's also possible we are also evolving the model. So the entire application is a kind of parametric with respect to the things that you can actually change and simulate. This depends on the actual model and how it is implemented. At the moment, you can visualize the outputs in terms of pollutants and some statistics for the vehicle using the visualization for having a visual impact of the results of the simulation. We are currently working also on implementing more sophisticated analysis tools for supporting the user in the what-if analysis, and specifically in the direction of comparative analysis to allow, for instance, the user to compare different solutions or to compile in a kind of timeline different simulation, like along the 24 hours that is subdivided in slots of 3 hours, but you have different simulation, and we are working to implement additional services to help the user in analyzing this data. And we are also working in the application of explainable AI for implementing sensitivity analysis, meaning that it can be also very useful for a user, not only to have the results of the simulation, but also to have insights on understanding how the results of the simulation are connected, are related, or are sensible with respect to the input parameters. Closing street, of course, has an effect. So we are working on this empowered, let's say, analysis services for CITYNEXUS. CITYNEXUS is deployed on top of the DestinE. We have here a schedule of the implementation. The service is at the moment coming soon. It's supposed to be available with the initial basic features that I am presenting here in July. And the service is not only using the DESP, but we have been also working, also providing feedback to the DESP and to the DestinE during the implementation. Here you see the services that we are either already using or we are planning to use in the near future. At the moment, we are using the infrastructure, the information dissemination, and the YAML accounting services. But we are also working on the implementation of the data workflow and dashboard services. And towards the end of the project, we will experiment the implementation of services for user workflow and data visualization. So as I said, CITYNEXUS is coming soon on DestinE. And we have been exploiting the DestinE, and the DestinE was instrumental for implementation of this application in its three main directions of purposes of goals of the DestinE, which is the platform, the digital twin, and the data lakes. In terms of platforms, which are the big advantages that, according to us, the implementation or the deployment on top of the DestinE can provide to CITYNEXUS, but not only. The platform in itself constitutes, in our opinion, a very good marketplace for your application. Gives you visibility, gives you deployment support, gives you an operational environment that you can use, some services like the account management, and of course can provide you resources. This application needs significant computational resources. Being in the ecosystem of the DestinE definitely simplify and empower the entire application. These applications are very often not deployed by big companies that can sustain the entire deployment and exploitation of the application. So being on the DestinE allows a lot of medium and small enterprises to being active in the EU application market. The second big advantage is the digital twin concept and the interoperability that the concept itself of the DestinE propose and foster. This interoperability is, let's say, two ways, because on one side, an application like CITYNEXUS can provide data for the digital twin. CITYNEXUS is in itself a smaller digital twin for specific aspects of the city of Copenhagen for the moment, but the concept is more general, can be extended to other cities. So this can become conceptually a building block or a generic twin, a generic digital twin. But also practically, it can be a source of data that can be automatically used and injected into the pipelines of a new application that would like to implement data analytics loop on top of digital twin data. This is one way. The other way is, of course, one also the main big advantage and possibilities that the DestinE offers is the possibilities of accessing data lakes, streaming data that you can use in your application. And this, of course, on one side, reduce the cost of deployment because you don't have to implement a specific software solution to access the different data sources. And on the other times, of course, with the concept of data lakes and with the concept of the fact that you have a big entity, the big brother like the DestinE that guarantees that this data, the freshness, the validity, the timeliness of the data, then can provide a big service for the EU application. So, in terms of platforms, the CITYNEXUS aims are implementing services of model visualization, simulation, and analysis on top of the DestinE. So the user basically is using the CITYNEXUS, but through the desk. So he knows he's part of the family, let's say, he knows he's part of the ecosystem. And then he can profit of the services provided by the system and can also generate data for the system. On one side, guaranteeing the access to the data lakes. On the other side, generating data on the DestinE infrastructure. Ultimately, extending the DestinE, providing this modelization, visualization, and simulation services for the specific goal and extension for which they are designed for CITYNEXUS, that is a city level. Our expectation, our hope, our aim is that this experience will go ahead and will be able to implement also to automatize this loop more. The more that the DestinE grows, the more that the services are stabilized and available, our aim is to automatize this loop, because the data are there, the services are there, the interoperability is there. Then we just need to make it more automated and working in this loop in such a way that it is not only an application that is used to the DestinE. Then the big advantage of the platform, that is in terms of data, the DestinE data lakes provides access to digital twin data and a larger number of external data space. Here we have a recap of the data that we use from the DestinE, and these data are used, and data out of CITYNEXUS are generated for the DestinE. So this is a kind of positive interaction that empowers the services and the possibilities of CITYNEXUS within the bigger loop of the DestinE. I would then leave the words back to Alessandra, that will tell us about the community and the perspective and future of this application.
Yes. So thank you, Simone. I want to spend a few words now to talk about, a little bit about how we are trying to build a community of practice around this system. So that is not something that we are developing based on an initial idea, but is really something where we have the opportunity to constantly check if what we are doing is relevant to the need of our stakeholders. We have engaged them in several occasions. We have held different meetings with and sessions with members of the local council of Amager West, and also try to involve as much as possible different types of stakeholders that have to do with the environment of transportation and urban planning and urban development. So all of them have expressed a strong interest in the usage in general of digital twin solutions as part of not only of their decision-making process, but also in terms of their engagement with citizen process, meaning that is a tool that they find extremely useful to really engage with the local community. We have also had the opportunity to showcase the very first visualizations of the system during a workshop that not only was attended by the local council of Amager West, but also by other 10 more nearby municipalities, all part of the Copenhagen, the greater Copenhagen, and also the suburban areas. And again, we were very happy to see that their interest in being able to see in almost real time the results of these kind of actions that can be implemented in the system in terms of other practical outputs, such as air quality or redistribution of mobility demand. It's something that has really good potential to provide a different insight into these transformations. We are hoping to engage further with the city of Copenhagen. There will be future events taking place before the end of the project. I want to detail a bit more on those later on. Simone, if you can go to the next slide. In particular, we really want to spread the word as much as possible on what is possible with this type of technology. Not only trying to engage with our, let's say, peers and the Earth observation and let's say and data science community through participation to conferences, but really we want to be part of the discourse on climate change adaptation. And for this, we plan on presenting an almost finalized state of this activity in September. At an event on climate awareness that will be held in Copenhagen, where we will give the opportunity to citizens and to stakeholders to try the platform and test different scenarios and discuss together the different results and the different outputs. So really to build a stronger awareness on the project. In terms of scalability, Simone, if you can go to the next slide. We are interested in really, we're planning in, again, as I was saying before, spread the word as much as possible and to try and involve not only, let's say, stakeholders in the city of Copenhagen, but to really extend this to other cities in Denmark, but also across Europe that are facing similar challenges. And we know that there are many. We are already, let's say, planning on understanding how to extend this solution potentially to other cities. and how to maybe make some different types of agreement with data providers, especially for the mobility part, mobility data component, that might help us constantly keep the data ecosystem of our mobility information active and up to date. At the moment, the model is designed mostly for supporting policy making, but we saw how people seem to be interested in using it at a more, let's say, at a communication level. So to essentially use it as an awareness building tool. And in this case, we are really trying now to think what could be the future of a service like this. For example, to implement it as a more flexible service that can be, for example, more openly accessible to all citizens, maybe with some simplified function and like more coarse-grained outputs of the model, but at the same time accompanying this with a more precise tool that it's more suitable for policy making, that has maybe higher computational costs, but that provides more reliable information. So at the moment, we're only going with a tool that really takes a lot of variables, a lot of information in, but it would really be nice to develop further the opportunity to have this as something that citizens can use just to experiment as a sort of game. Yes, so I think that is all from me. We're happy to take any question, so please feel free to ask.
Thank you very much, Alessandra and Simone. So we now go into the Q&A part of today's webinar. I'm Rob Carrillo from Trust IT Services. I lead the communications and events in the ESA DestinE Platform use cases project. So how we're handling questions is please do add them in the Q&A. However, I also see that some of you have added to the chat. Don't worry, we're keeping an eye on that. For some of you, we'll provide also the opportunity to speak live, so just prepare. We have our first question from Nicholas Wern from Winio. Nicholas, since you have quite a few questions, we'll also provide you the option to speak now. So yes, so Nicholas, maybe you can tell us a little bit about yourself, and please do state the questions.
Yes, can you hear me okay?
Yes, yeah.
Okay, awesome. Thank you so much. Super interesting platform, super interesting use case as well. My name is Nicholas Wern. We're working with the concept of digital twins in real estate, I think for the last 5 years, building automation for 8 years, background basically in innovation and IoT, but now also bringing autonomous buildings platforms to market. But I'm in the Digital Twin Consortium in the US, responsible for, well, all this kind of stuff as well. And also with Chalmers DTCC here in Gothenburg in Sweden, and also part of the MIMS initiatives, a couple of them. I was working on data models, but also looking at it from a holistic perspective, looking at it from a participatory approach. So I think like I had a bunch of questions, but I can't really access them now. So let's see if I can
help
see
you.
them. Yeah, so I think, yeah, no, I see them now.
Yeah.
Thank you.
Okay, go ahead.
Sorry. Yeah, thanks. So I think like the first percent, mentioned like who are they? They can use it in terms of the platform, but is that the urban planners or is that also the citizens? I think maybe I got the question later on, but that was one of the questions.
Mm-hmm. Yeah, I mean,
yes.
the system was primarily developed for use in planning context. So it's really something that came with the local municipality, and it's meant to be a decision-making support tool for urban planning, urban design decisions. But as I was saying before, during the different conversation that we had with the local stakeholder, it became clear that it's not only a tool that can support planning, but that can support the experimentation with citizens and raising awareness among them. So we would like to see if this can be developed in the direction where we have a simpler tool, a more streamlined system that can be used free of charge anyway, in a more open way by citizens. And then, of course, a tool that it's more specialized for planning.
Yeah. No, great. Yeah.
Let me just compliment on this. We focused so far on the, let's say, core part of this application, which is the model behind it. The objective was to build something that was not simply a toy. It's possible to simulate these things, but not really. This tool has been designed for providing actionable results that can be used by really policymakers. Now things are starting to be interesting in terms of interaction and users. So now we are deploying the application around the modeling with a solid ground that the modeling part can provide good results. And then we are collecting user feedback, and we are implementing services on top of this core that can hopefully reach a wider audience, maybe with different expectations and different needs. Not only in terms of user interface, graphical user interface, but also in terms of how to provide actionable knowledge to the different type of users in such a way that these things can be actually usable by.
I mean, super interesting. I think, like, just a recommendation is also say, like, today this takes 10 people 5 months to get nowhere. With our tool, they can just run these simulations. It takes 5 minutes, and then the time saving or the cost saving is always super interesting. But the next question, and if I'm allowed to ask more questions, do you have any ideas how the platform relates to the MIMS, the minimal interoperability mechanisms? Have you been involved in that work as well? And open data spaces, cityverse aspects in the EU?
No. Can you tell me a bit more about this?
Well, I mean, it's sort of similar. MIMS are about the minimal interoperability mechanisms from OWASP. You can just Google it, I guess. But it's just like how these platforms come to market, how to help municipalities procure these kind of tools and solutions so that they adhere to, again, different interoperability perspectives, mostly technical. But definitely what is coming up stronger is fair AI. Are citizens involved? Is it just urban planning for people, or can people actually be involved? Or are they be the ones that are actually driving the change in the city where you democratize this? So just have a look at it. It's just more of a yes or no question. And then I was also asking about, again, understanding that this is more the planning and the simulations, create a way to document the different possibilities. In the parameters that you bring in, did you also have like costs or other, measures that are tied to maybe vendors or the cost of actually getting it done? Because you had putting it, something, the highway underneath the city versus, above land. I understand like the time aspects and the impact might be beneficial, but the cost to get there might be, again, is the juice worth the squeeze? And, taking in budgets from the planning aspects as well? Or what are the different parameters? I understand like you had the, the CO2 aspects and, congestion, but again, like cost and these kind of things relevant to what they're doing today. Is that a parameter that you brought into the platform as well?
If I can just a little bit comment on the costing part. So the system itself does not take into account the cost, the economic cost of this transformation. But we have a clear idea of what is the size of the intervention that are envisioned for at least some of the, for example, road tunneling. These are not, let's say, we are not here to provide them with this particular tool a solution on costing or budgeting this intervention, but we know that these interventions are currently being discussed. Specifically the originating, let's say, element of this project, which was the possibility to tunnel the Øresund motorway in correspondence to the urban area of Årestad, is something that was brought to us directly by the local council, and that was something that involved like multi-million projects that are still in the process of being decided. So we know that the decision will be something that will happen in the coming years. We just want to give a voice that is not currently being considered. They are making important considerations in terms of noise, in terms of CO2 emissions related to the implementation of this type of project. We want to give them an additional idea on what would be the impact in terms of, for example, air quality. But yeah, no, that's a fair point. But at this point, we don't have plans to include budgeting or economic costing in this simulation.
Okay, thank you.
Okay, thank you for that, for your questions, Nicholas. So next, you see we have a question, raised hand from Georgie Mercer. Georgie, are you still there? If so, you should be able to speak now. Perhaps you can introduce yourself really quickly. Or I see the hand is down now. Maybe there's no more question. Okay, perhaps you can go to the next question instead from Christine. Do you have plans for interaction with national climate services? Also, for example, the Danish Climate Atlas.
So if I understand correctly, the Danish Climate Atlas is basically a tool or like data that the municipalities use to understand the impact of climate, of like different types of environmental factors. For that, we are relying on the information that is already provided within the DESP. And so it's the element of data integration between what we are, let's say, develop in terms of mobility, which come from external providers, and what is available within the DESP. But at the same time, we are also inputting in the system a lot of data sources that come from what is already openly available in Denmark. So we'll definitely have, we have not included, for example, the service you mentioned, but we will definitely consider that because it's an element that might help us improve further the, especially the air quality simulation component of the system.
Okay, Christine, you have the permission to speak. Yeah.
Thank you very much, and thank you for the nice presentation. I come with a different angle than the other people posing questions. I'm from the Danish Meteorological Institute, and in Denmark we have the role as a climate advisory authority for the Danish government. The Danish Climate Atlas is a tool for the municipalities, as you say, that provide climate information, sort of officially, so to say. And I'm asking because we do our best to provide some authoritative information. And we build upon DestinE and Copernicus, but we also put in local knowledge to make sure that we give the best possible information to the municipalities. And of course, we have a very keen interest in having people like you building upon this kind of information to make sure that the municipalities and other stakeholders get the best possible information and that we don't get climate information that points in different directions. So that's the background of my question. So we'll be very happy to interact with you and make sure that you get this information.
Yeah, absolutely. Thanks. No, that would be really nice. Also because Denmark has, in our professional experience, some of the most really relevant pieces of data available for this type of activity. So we are always happy to interact with the data ecosystem of Denmark. Absolutely, they haven't in that sense. But thank you very much. We'll be in touch.
I think that sounds very good. I think also we get closer to within the weather forecasting. We have this dialogue on when we send out a warning for dangerous weather. It's very important that it comes from the authority to make sure that we don't have confusion in a difficult situation. I think we're approaching with this more advanced systems, we're approaching some of the same challenges that when we come in as DestinE with EU logo, it's very authoritative. So it's very important that the different authorities come with the same information. maybe this is a dialogue that we need to boost in the next years also.
Yeah, point taken.
Okay, thank you for your comments and your question, Christine. Next, we have a question from Guglielmo Ricciardi. Guglielmo, you have the permission to speak now. Perhaps you can quickly introduce yourself and then tell us your question.
Yes, Rob. Thank you. Can you hear me?
Yes.
Thank you, Alessandra and Simona, for this very stunning presentation about the DestinE project. And I'm a researcher at the CMCC Foundation, the Euro-Mediterranean Center on Climate Change in Italy. And I'm an expert in climate change adaptation in urban context. And during my PhD dissertation, I've been involved in the development of some quantitative and qualitative key performance indicators to engage in the urban digital twin, and I'm interested on understand if you have considered some quantitative or qualitative KPIs to assess urban design scenarios in the digital platform that you are developing. For example, related to building context, open air spaces, I don't know, people, or for the each components of the built environment.
So the system is basically designed to allow for comparisons. Okay, so it's very difficult when you introduce a single change, maybe in a part of the network, a new rule. You transform the accessibility of a specific street, or you add new point of interest. You imagine to have more people living in a certain area. You're making changes that impact not only that specific place, but that have like ripple effects, which can be kind of trade-offs. If you reduce congestion in one area, maybe you have improved that area, so you would have like a positive outcome in terms of, for example, air quality in that specific area. But maybe you have rather redirected a lot of mobility to another district or another neighborhood that actually is suffering from it. So instead of identifying like an index or a value that really evaluates, okay, actually you really did good job in this overall scenario, we are actually allowing people to run different scenarios, to save and store these different scenarios separately, and then to measure to see basically the before and after. Where is that they have improved the situation, for example, with a reduction of NOx levels in a specific area? Where is that they have made it worse? So to understand also that these kind of complexities. The idea is to have really, we are still understanding with user what would be the best way to communicate it in ways that is more relevant to how, for example, municipalities make use of this data then in planning context. But for example, to understand for specific areas or for specific areas of interest, the different parameters, how they compare between different scenarios that are run. We are still looking into what is the best way to do that. But at the moment, we are really keen on staying away from, let's say, a single number that can give you like a thumbs up or a thumbs down, let's say, because it's so much more complex than that. But yeah, basically this is the approach that we are following up. Now we have in this phase of developing of the project of the CITYNEXUS project, we are in the phase where we have the first tests of the simulation capabilities, and in the next months there will be more interactions with the end users to understand if we are going in the right direction. But definitely, you know, also if you have done research on this, that's super interesting for us. So if you feel like pointing to some resources of what you've been working on, we'll be very happy to have a look at it.
Yeah, this can be also part of the, let's say, sensitivity analysis that we are starting now, where the goal is, of course, not to give the thumbs up or down, as Alessandra said, because this is at the end it's a fully connected living network somehow. So it's you have effects everywhere from one point, but not to. It depends. You can analyze what kind of extent these effects can be, and using this type of analysis, you can propose information about the correlation of different factors, not only on the KPIs, but also, let's say, geographically speaking, depending on this area or that area. This is part of the activity that we are doing, but as Sandra said, we are driven by the users here, because we have an active user community that is really keen to try and to use these things. So this will also depends on the actual needs of the user. But technically speaking, this can be part of the analysis and the explainability of the explainability analysis of the different decisions that we are currently doing.
Okay. Thank you very much, Guglielmo. I see we only have 4 minutes left, so we'll just take the Perry Andrews question online now. But for the last remaining questions, we'll just take them one by one. So, Perry, are you with us?
Yes.
Yeah?
Hello.
Okay. Yes, we can hear you.
Hi.
Okay, please briefly introduce yourself and state your question.
Yes, indeed. My name is Pere Andreu Ubach. I am a researcher at CITYNE, which is the International Center for Numerical Methods in Engineering in Barcelona. And in 2009, we started devising a platform that is analogous to what Destination Earth aims to achieve, however, at a more downscale level at the regional government, in collaboration with the regional government of Catalonia. And it very much follows the structure of Destination Earth, of having digital twins, of having a registry of the data on the land and the soil, and trying to model and simulate the processes that may represent challenges for the regional government on policymaking strategies. Therefore, I would like to ask, what is the approach for larger size entities like regional governments from Destination Earth? Are you planning to collaborate beyond the main cities? Because at the scale of urban planning, regional governments have more powerful instruments for land planning and preview directives than local governments. What's your view on that?
I can take this. So essentially the solution is scalable. We can understand the patterns that are not only relevant at an urban level, but they actually work at much broader level. Of course, when we talk about maybe regional authorities, they are less interested in knowing exactly the impact of a change in that road segment, but maybe they are interested at coarser aggregation scales. We have worked on similar activities as, for example, as Mindurst for entire regions, and understanding, for example, the impact of mobility between regions or within region, and linking that to the typical travel patterns or typical, for example, vehicle emission pattern, to do something similar but on a different scale. I think the whole problem would be targeting the right scale, because as usual, you can go very, very detailed, but maybe that level of detail of information is not relevant. So for CITYNEXUS, we are specifically targeting cities. But in principle, there is nothing that would make us say no if we would have to rescale this type of solution to like address more regional level problems. So that is something that it's possible and it's extremely interesting. Within the limited, this is a 1-year project, so within the limited time that it's devoted to this activity, of course, we had to make a decision, which comes with the additional design decision and simulation decision. So, but yeah, I mean, it's true. Regions have the authority when, you know, for example, designing large infrastructural projects. So they are an important person to have at the table.
Okay, thank you very much. I have left the link of the project we've been developing. If you might be interested.
Yeah, thanks.
Thank you very much, Per Andrew. Now we'll just take the questions one by one and read them out. We have a question from José Luis Fernandez Villacanas from the European Commission, who asks, how do you deal with unexpected emergent behavior characteristic of these systems? Would like to take that.
Unexpected characters behaviors.
Maybe I can provide the permission to speak for José Luis, if you can clarify really quickly.
Yes, can you hear me?
Yes.
When you model these systems composed with different sectors, with, as Alexandra was saying, with lots of feedback loops in between the sectors and things, you don't have a full knowledge of the system top-down. So you normally have to model bottom-up, okay, with something like multi-agent systems. And then these simulations give you sometimes unexpected or unpredictable emergent behavior like traffic jams or collapses of avalanches of people or network grid lockouts and things like that. So I was curious to see what kind of models you were using to account for this unexpected behavior, or if you were taking these things into account at all, because I am sure that you are observing these things in cities. Huh?
At the moment, we implement a very detailed model. Maybe Alessandra can give more details about the model. It can be interesting, but this model does not take 10 seconds to provide results. This depends on a lot of factors, but this system for the simulation part at implementation level is not supposed to provide results in real time. Okay, so you run the simulation, you have your workspace. The simulation at the moment in very complicated situation can take up to 3 hours for providing the results. So you have your workspace, you define different scenarios, you run the simulation, you get notified when your simulation is ready, and then you have the tool that helps you in putting together the results for the analysis. On top of this, and using this, of course, this depends also on the computational capabilities that are put on the ground. We are talking about the computational capabilities that are provided at the moment can be provided by the DestinE. These things runs on an OVH cloud. And then on top of this, it's possible to train a regression model that will be much more faster and less accurate and precise than the real simulation. So here it comes the different user profiles, depending what you need to do with this tool. If you want to have fast results to give you an idea, then the regression model can provide you almost in real time actionable results for getting an idea. If you are the Amager Best District and you really want to put an highway underground, then you better to wait for the results of the simulation, because in this case you get much more precise results.
If I can add some additional details on the model. First of all, the system that we are using to so the base model is a deep gravity model that takes into account basically different factors and allow to avoid the problem of this kind of unexpected aberrations. Of course, there are in terms of results that are unexpected, in terms of I'm gonna introduce a change here and that would have negative effect that we did not expect from the simulation itself to another location. This is part of the game in a sense. So we actually want to see what are the nonlinear effects in other areas that might at the very first look appear as not impacted. We also have validated the results of the model on actual traffic counts to understand whether we are able to really capture real, let's say, for example, congestion patterns or presence of vehicles in different types of street segments. For that, we use an open data set of traffic cameras that is available for Denmark. And we had very, very good results, meaning that our model is very close to being able to actually count the real number of cars that are seen in a specific moment in time. The base model that we are using is based on Sumo, which is a very solid and robust simulation system that was developed by the German Aerospace Agency. So it's a very strong system. But I mean, in general, we have some internal steps. I cannot go so much in the technical details, but we can definitely provide them if you're more curious to know about this. But again, both the Sumo system is quite robust in this sense, and also we have different constraints and validation system that allow us to understand whether what we are saying actually corresponds to what we can observe.
All right. Thank you for that question. We have the last one from Malik Terfu, who asks more about the workshops that you discussed earlier. He would like to know if you can elaborate on how you decided who the end users were that you were targeting for the service, and how did you manage the relationship with them, and how the workshops were conducted.
Okay, so we had two different types of approach for user engagement. In all of this, we were basically supported by Urban Digital, that is a Danish company that actually works to put in touch different types of stakeholders and support both the municipality and the civil society, essentially to come together to understand different types of policy issues, or let's say issues of public interest. The main two mechanisms that we put in place for this was, first, a set of bilateral meetings with key stakeholders from the local council of Amager West. These meetings were carried out primarily with the support of the Urban Digital team, and they were conducted in Danish. So the first aim was to raise awareness about the project, provide an overview, and also elicitate from their point of view who could be additional stakeholders that might want to be involved in the process. In addition, together with Urban Digital, we identified other stakeholders that might be involved. I'm not going to be able to pronounce any of them by correct spelling, but for example, we had the Port Neven group that deals with, for example, infrastructure. We had a think tank for urban development that has been involved in several of the projects that are occurring in Årestad. And in addition to that, with time, we were able to, through the local council and the municipal and Urban Digital, we were able to raise awareness among other municipalities within the broader area of Copenhagen. I'm going to try to mention a few of them that were involved in the workshop that took. So the last workshop actually took place in end of April and involved 10 representatives from 10 different municipalities. I'm going to try to pronounce it, but it's not going to be a very good pronunciation from my side. So we had the Genoft municipality, we had Rodover, Vellenes, Gladax, and some other municipalities that were at least represented in this event, and they had the opportunity to test this to give us a feedback on this very first visualization. In these very days, Urban Digital is leading an additional event with a group that is basically a citizen science-led group, because they see a lot of potential in using this tool as a citizen science instrument. I think it's a group that is called Democracy Now! That really wants to bring the data environment closer to people. But because, of course, we do not have, as companies that are based outside Denmark. We do not have the inside knowledge on who are the players that might be interested in. This kind of intermediary is really helping us build a stronger network with the local partners at different scales. So from very local to municipal and hopefully other cities as well in the future.
Thank you. Unfortunately, that's all the time we have for Q&A and for this webinar. I just want to thank everyone who stayed here with us, and most especially to our speakers, Alessandra, Simone. Thank you very much for sharing some of the insights from the use case. Very, very interesting. I just want to remind the audience that we do have some upcoming webinars, roadshow webinars. The next one on renewable energy forecasting through the DestinE platform, and that's on the 2nd of July from 11 to 12 CEST. Followed by the next one on the 9th of July, Urban Square, DestinE Empowering Urban Resilience Against Climate Challenges. So we look forward to seeing you in our next webinars. For those of you who would like to revisit the slides and the recordings, please go to the event page on the DestinE website so you can access the slides there, I think, within this week. With that, I think we can close here. Thank you very much, everyone, and goodbye.
Thanks, everybody.